Hello. I'm going to be recording the exam questions and how to solve them as best as I can explain them. The only one, just to let you guys know, I am not going to do is question number 4. I believe that's question number 4. Yes, which was one in which most of the class missed. I believe that was out of all the long questions. It was like 30% of the class missed that one. But my reason for not going through that one right ahead of time is that Dr. Tolman did that on the 12th as recitation. So you can find that on Echo, and I don't need to necessarily go through that on my own. So let's get into this question. A 96 kilogram patient in the ICU is in a hypertensive crisis with a blood pressure of 224 over 104. And the nurse goes, "Oh my gosh, what do we give him?" And you look at your chart because you're a handy dandy pharmacist and you have that on hand, and you say, "Give him 20 milligrams, stat." And then 5 minutes later, you check on the patient and you get, you don't check on the patient. You tell the nurse to check on the patient 5 minutes later and tell you what the blood pressure is. She calls you back and she states that the blood pressure is dropped, but it's still high. It's 190 over 97. Oh my gosh, what do I give him? And you say, "I'm a handy dandy pharmacist and I know what I'm doing." And you give them 15 milligrams for the second dose. And she hangs up the phone and gives that to the patient. So, you decide, as the handy dandy pharmacist, that you don't want to kill this guy, and that you're going to look up the how much total you've given him, and you know that the drug eliminates after a while. So you look up the half-life, and you also look at the volume of distribution, and you're going to write this all into the chart. You're a professional person. So the patient is 96 kilograms, and for the first dose, you gave them 20 milligrams, and for the second dose, you gave them 15 milligrams. Now, is this an IV or a bolus dose? This is a bolus dose. You just have 2 bolus doses. So the way that we're going to find this is concentration of loading dose 1 and concentration of loading dose 2. So let's find the volume of distribution, because we need to find that in order to find the concentration. So, because we have the dose, we need to find the loading dose, we need to find the rate of elimination, and we need to figure out the time as well. Even though we've been given the time, I'll explain the time because it's a little bit tricky and I can see why people got tripped up on it. Especially if you weren't doing any of the practice problems on your own, like any of the practice exam. The practice exam was very helpful, guys. So, and if you watch my previous videos, which I think about 30 of you did, obviously people needed help with that. I mean, kinetics is a difficult thing. I will very much say that kinetics only gets harder from here. But if you keep up with the practice exam is always the best way to go for this kind of class. At my old school, we were not allowed to have the practice exam. So, yeah, we had upperclassmen quote unquote make us fake exams in our little study club. But I think that what they did was they just changed the numbers. It was the same exact exam, but that still helps you. And good thing Dr. Tolman recognizes that we do need to see the practice exam. And I think the reason they didn't do that at my old school, Alright, let's find the volume of distribution, which we just take the 96 kilograms. So while I'm writing this, I'll say, at my old school for toxicology, when I took kinetics, we had open note because it was calculus derived kinetics. It was not. This is much easier being able to plug and chug. So that's partially why they did not give us the old exams in that class. So thank your lucky stars. You weren't me about 3 or 4 years ago. All right, so what? Now we need to. I need to visualize the time because we found the volume of distribution, the rate elimination, but the time is a little bit tricky. So I'm gonna 0. All right, let's do 7 minutes there. Let's do 12 minutes there. So our first dose is that's time is given at time 0. It's the first thing. That's the first thing, and so we wait, and it starts to eliminate. And what ends up happening is that the nurse gives the second bolus dose after 7 minutes, and then that eliminates out. So we are supposed to find the total concentration after another 5 minutes after that 7 minutes. So 7 plus 5 is equal to 12. That's how I found the 12 here. So this is our timeline, and this actually helps. So our first dose is still eliminating, technically, by the time our second dose is being administered. So it's still there, but it's probably there in a added concentration on top of the other dose. Now, why did I put this little squiggly here? Well, that was just to make this easier to draw. But if you actually looked at this chart in real time, because the half-life is 6.5 hours, I mean, that's a huge amount of time, and you're doing it 5 minutes apart. So if I actually drew this out in real scale, that means that you skip scale. If I drew this out in real scale, what would have happened is that this and then this. Like, it wouldn't have been, I wouldn't have been able to show that. So that's why I drew it the way that I drew it. But, so our times, so we've had this one going on for 5 minutes. And this one has been a total of 12 minutes. Okay? So our dose 1 has been running for 12 minutes, and our dose 2 has only been running for 5. So that's the times for those ones. So this is, this I would say is T for dose 1, and this is T for dose 2. So if you want to put a little 2 or a little 1, that'll help. Whatever helps you. Whatever floats your boat, guys. So now we're just going to do 2 loading dose equations, which our loading dose equation is dose over volume of distribution, rate of elimination, negative KE times time. But because we have 2 loading doses, we're going to add them together, and we're just going to do 1 is dose 1, dose 2. It's the same rate of elimination because it's it's the same volume of distribution because it's the same patient, and it's the same rate of elimination because it's the same drug. We're not giving 2 different drugs. It'd be cool if we did 2 different drugs. I have had to do that before, so it's not out of the limit for maybe another exam. So just keep that in mind, in the back of your mind, that that's that could be a possibility. Make yourself a practice question that could be with that. So that is our concentration loading dose 1 is this whole entire section, and our concentration loading dose 2 is that one. So let me write this out. So our first dose that we gave them was 20 milligrams, and our volume of distribution for this particular patient. And then our rate of elimination for this drug. And then the time. So for the time for dose 1, it's going to be 12 minutes, but the issue is that our rate of elimination is in hours. Oh, I never did find that out. I did find that out. I just forgot to write it. My mind is working at 1,000,000 miles a minute today. So if you entered that into your calculator, you would have found that, which I put over here. But that is in hours, and this is in minutes, so you have to convert it to hours. And then you do the second one, which the second dose we gave them was 15 milligrams. And it's the same patient, so it's the same volume of distribution. And it's the same drug, so it's the same rate of elimination. And now, how long has that second dose been in that patient? Only 5 minutes. It's only been in there for 5 minutes, but it needs to be converted into hours. And so if you do these, you will find that this is 0.3396 milligrams per liter, and this is 0.258 milligrams per liter. And you find that the total is 0.5976 milligrams per liter. I am sorry, my writing goes sideways all the time without lines. Alright, but so that should have been your answer for the first one. I will see you on the second one. Adios, amigos.